Hello. Now, today we're going to continue our work in algebra and we're going to be looking at simultaneous equations, and we're going to be focusing on or doing out simultaneous equations with three variables. So here I've got x, y, and z all going on at the same time. Now, we don't touch on this very much in our course, but just to highlight it to you, z is the letter we would use for the third axis. So pretty much all of our maths involves x and y, which are two dimensions. So you can imagine it going forward and back, side to side. Z is up and down. So it's the third dimension of space that we tend not to deal with in secondary school maths, because it makes the mathematics of moving around an awful lot more complicated. But technically, these are in the same way as x plus y is equal to 5 would be the equation of a straight line. This is the equation of a plane, effectively of a sheet of paper sitting in a three-dimensional space. So this is all of the points where you would have your x value plus your x coordinate plus your y coordinate plus twice your z coordinate equal to the number 3. This is just an aside. It hasn't come up on the exams yet. It's just that is actually what this equation is describing, and it is theoretically on your course, so it's better that you have it in the back of your mind, but we don't need to focus on it. What we do need to be able to do is handle these in the exam, and the method for dealing with these is straightforward but very bitty. So it's a more extreme example of the two variable simultaneous equations that we already know. And it is important that, just before we jump into it, that this is the last question you would ever do on a test. Not because it's difficult, but because it can be a bit of a black hole for time. You can disappear into these questions and come back out 10 minutes later having achieved very little. So even though they're not complicated, they're something that we do when we've done all of our other questions, and we can come back to this if we have time at the end, because they can really be a huge time sink in an exam. Now, the method that we're going to use for solving this is probably not too unexpected. We're going to eliminate a letter. In this case, I'm going to get rid of the z's, because I can see it just opportunistically is the easiest thing to get rid of. So if I add, without having to do any work, if I add my first equation, let's label these equations. If I add my first equation to my third equation, without having to do any work, the z's sum to 0, and I'm left with an equation only involving x and y. And I'm going to then multiply my second equation by 2 and add it to the third equation, and that will again get rid of my z's. They'll sum to 0, and I'll be left with another equation in terms of x and y. And then I'm just solving simultaneous equations with two variables, just like I already know how to do. But you can see that this is going to go on a little bit. So let's jump into it. I'm going to add equation 1 to equation 2. To equation 3, I should say. And you can see I'm labeling what I'm doing as I'm going because of how messy this gets. So if I add those together, I get x plus 2x is 3x, y plus y is 2y, plus 2z minus 2z is 0z, is equal to 3 plus 9 is 12. First part done. Next thing I want is twice equation 2, which I'm going to write down. So doubling equation 2, and I can write in some brackets here. Doing the multiply in these things can very easily to mistake, so writing in what you're doing in as many places as possible is good. So I have twice 4x is going to give me 8x, plus 2y is going to give me 4y. Twice z is going to give me e plus 2z plus 26, or sorry, equals twice 13 is going to give me 26. Now I did that again so that when I add that to equation 3, my z's are going to sum to 0, so I'll be left with two equations in terms of x and y. So now I'm going to take my twice equation 2 and I'm going to add it to equation 3 to get my z's to sum to 0. And I'm actually going to rewrite my equation 3 underneath so I don't make any mistakes. So when I add those two things together, I'm going to get 10x plus 5y plus 0z, which I'm not going to write down, equals 35. Now I'm going to label these equations that I've got. So this equation here I'm going to use, so I'm going to call it equation 4. This is equation 5. Now what jumps out at me here is that equation 5 has a common factor, and anytime I'm doing any algebra or really any maths of any sort, if I spot a common factor, I want to take advantage of it. If I'm dealing with big numbers in simultaneous equations, I'm more likely to make a mistake, and I want to avoid that. So what I'm going to do is divide equation 5 by 5, because I can see I've got a common factor of 5 across all of my terms, and that will make my numbers smaller and therefore easier to deal with, more manageable to deal with. So I'm going to write that in as a note to myself here, and I'm also going to write it in underneath what I'm doing, dividing all of that by 5. So I end up with 2x plus y is equal to 7. Much nicer equation to deal with when I'm trying to do simultaneous equations. And I'm going to call that equation 6, VI. So now when I do that, I'm going to write out what equation do I want to use with that. I want to use equation 4 with that. So 3x plus 2y is equal to 12 is my equation IV. And these are the two now that just involve x and y. So now I've got simultaneous equations with two variables. So this is exactly what I've been able to do since junior cycle. So we know exactly what we're going to do. The easiest one to get the same here is multiply my equation 6 by minus 2. So if I do that, I'm going to get minus 2y up here. So when I add it to my equation 4, my y's are going to sum to 0, and I'm going to be left with x's that I can solve for. So that's going to be minus 4x minus 2y is equal to minus 14. And I have 3x plus 2y is equal to 12. When I add those two equations together, that's equation IV. When I add those two equations together, my y's sum to 0. And I get minus 4x plus 3x is minus x, or minus 1x if you prefer, plus 0y is equal to minus 2. Rearranging, x is going to be equal to 2. That's my first letter gotten. Now I'm going to go back to one of my previous equations, whichever one I think is easiest to deal with. And I'll take 2x plus y is equal to 7, so my equation VI, with the knowledge now that x is equal to 2. So I sub that in and solve for y. So y is equal to 3. And now I go back and I remember that I have z defined as well. So I have x plus y plus 2z. I've just picked one of my 3 original equations. Why did I pick this equation? Because it has the smallest coefficients, so it's the easiest not to make a mistake with. And I know that x is equal to 2 and y is equal to 3. So now I sub in 2 plus 3 plus 2z is equal to 3. 5 plus 2z is equal to 3. Rearranging, I don't want that 5 on the left hand side, so 2z I should say, is equal to minus 2. Divide both sides by 2 to get z by itself, and z is equal to minus 1. So what we've got now then is our final answer of x is equal to 2, y is equal to 3, z is equal to minus 1. And that is the solution to our 3 variable simultaneous equations. So you can see the maths, very, very simple, but extremely important that we have these habits built up of labeling exactly what we're doing. Otherwise, we get lost, we make mistakes with signs and get things muddled, and these questions can spiral out of control. But if we're careful with our notation and make lots of notes to ourselves as to what we're doing, we can keep track of it, and these can be good banker questions to do at the end of a test. But they are what we always do at the end, because spotting that you've made a mistake is very, very hard in this big mess of equations that keeps being changed all over the place. So that's our method. We eliminate our third letter. In this case, I eliminated z out of 2 of my equations, and then I was treating them again like simultaneous equations that I've done since second year, where I have 2 variables and I'm going to cancel out one of them and then sub back in sequentially until I get all 3 of my variables back. So very similar to our 2 variable problem, but can get a little bit messier, as you can see.